Hi there once again and welcome to another Expresso Mechanics tutorial, and in this one we're going to be looking at building this, which is of course a level crossing that automatically works. In order to achieve this we're going to be using a combination of Expresso and Python. In fact, Python plays a major role in the creation of this one. That's what we're about in this tutorial, so without further ado, let's see if we can make this happen. I'm not going to build this one from scratch. I'm simply going to take you through what I've got in the scene. What we have in here, we've got two targets, or two pairs of targets I should say. So our first two are over here, and these are the ones that trigger the barriers coming down. Over here, two more, and these are the ones that trigger the barriers raising up again after the train has passed. So just null objects. I've only put them into another null to group them for the sake of keeping things tidy. So that's the targets there. The barriers, all simple stuff, just made from a cube. The main body of it made from a cube. There's a tube there, and then the left arm, I've just got an extrude NURBS with a spline that I've fashioned into the shape of a barrier. Exactly the same, of course, for the right barrier. And the null, the null actually contains what I'm calling the loco. It's only a cube, of course, again, which has been fashioned there. If you want to create a better train, then by all means do. But for our purposes here, a cube is fine. And it's grouped into a null. The reason I've done that is because if we go into the top view, what I've got, we can see if we look at the null, and it's over here, it's actually following the outer spline that makes up the two sets of rails. So I put the loco into the spline so that I could move it into the middle between the two of them. That's why I've done that. Okay, and then we're just using an Alain to spline to run the loco around the tracks. All of this is perfectly simple and straightforward. There's really nothing clever about any of it. And then a cloner here which creates the sleepers for the rails. And of course the sleeper is nothing more than a cube that's been reshaped and resized until it resembles a sleeper. And I've also put a small fillet on it too. And then finally we've got a sweep NURBS, or two sweep NURBS, that are creating the actual rails that go around the tracks. That's all we're doing. So it's very, very simple stuff that you can easily do yourself if you wish to. And that basically is what we're about here. So the next thing we really need to do is give ourselves another null, call it Expresso. And then give it an Expresso tag. The editor is open and we're ready to start work. The first thing to do is to open up our targets, select all four of them and drag them into the Expresso editor, and we'll just align them in two pairs, and we'll give them at our output stage, it will be coordinates global position for each of them. And then we'll just make them bigger so that we can see what we're doing. Great, so we've got two pairs of targets ready and waiting. The next thing to do is to bring in our loco, which is of course on our null here. So we'll bring the actual loco in, drop it in here, and we'll give this an object port at the output. Moving on from here, the next thing we need are two ray collision nodes. So we'll bring one in and then command drag to copy. And we've got those two there, and we can connect everything up. So what I'm going to do is just grab a hold of my object port on this one and just move it to the bottom. And then connect my targets to the two ray points. It doesn't really matter about the ray point order. I'll tell you what we'll do though. If we just take those away, and I'll put ray point 1 back at the top where it should be, just for the sake of keeping everything clear. put my object in there, and then connect these two up. So that's everything connected up thus far. Now, the ray collision nodes, they're in test only at the moment. We don't want that on, so we can check that off. But we do wish to use global coordinates, of course, because we've got global positions. And we do need to because our targets are grouped. So global position is going to be essential. The next thing I'm going to bring in are my arms. So if we go into our barriers here, I need my left arm brought in and my right arm. And these at the input stage, we're going to give them position, or rather rotation, I should say, rotation, and it will be rotation P. Rotation P. Make those a little bit bigger so that we can see what's in them. And now the final stage of the Expresso is to connect these two with these two. And in order to do that, we're going to be using a Python node. But before we go there, let's just see what's happening here. So we've got our two ray collisions, and we've got a result that's going to come out of them. So let's if we get a couple of result nodes and see what's going to go on. Because there will be people out there who've not seen any of this work before. So if we get another one of those. Now at the moment, there have been no collisions. So both of our results contain zeros. If there is a collision, we'll get a 1 at the output. Okay, that's what's going to happen here. So in order to make a collision happen, we need to send our loco around the track. So let's just see what we can do here. Now we can do this because I've already got a couple of keyframes set up on the Align to Spline's position parameter, one recording at 0%, one at 100%. So let's have a go at this and see what happens. So our train starts to move and it goes to there, and as you can see now, it's passing between the two nulls, and when it does that, it gives us a collision here. So we're getting a collision at our first checkpoint, because we can think of these as checkpoints, one which is going to lower the barriers, one which is going to raise them. So at this moment, we've got our first checkpoint is positive, so we would need to trigger the lowering of the barriers at this point. So we'll keep that going through, and now it's 0 again. That's fine. Let it go round. And we've hit our second checkpoint, and now of course we've got a 1 here. So we've got two separate triggers. That's what these ray collision nodes are. They're going to be two separate triggers for what's going to go on in a Python node. Okay, so that's how this is working. So let's just bring that back to 0. Take away the result nodes, and we'll reach for the all-important Python node. And that is the next stage, and it's code all the way from here. Actually, before we go there, let's just go in a little bit closer to what we've got on the tracks. If we just select these two and just say objects, now we're between the two and we can see where they are. So the two spheres that we've got in the window here are the two nulls, and you can see that one is just below the tracks and one just above, so that when the loco passes through, it's actually breaking an invisible beam between the two of them. For anybody who doesn't know, I mean, if you wish to know more about the ray collision node, then please take a look at my ray collision tutorial, and I've just put a card up on the screen to take you to there. So if you want a quick expose of how the ray collision node really works, that's the tutorial to take a look at. But anyway, let's just undo that positioning of the camera and go back and start work with this Python node. The first thing I'm going to do, as I so often do, is delete the ports at the input stage and add two new ones, and these are going to be integers. Input 1 I'm going to rename, and I'm going to call it down, and this one I'm simply going to call it up. At the output stage here, let's just check the port information. It's a real value, so it can remain, and we'll call this L and R for lower and raise. And that's all we need to do with our Python nodes inputs and outputs. Moving on from here, we can start looking at the code. So let's just select this. We'll say open in Python editor and then switch to a script. And we'll, in fact, we need to reselect it because of the way Cinema 4D works. And if we just go to here, okay, great. Right, so global LR, that's fine, or L underscore R, I should say really. That's already in, so that's our output taken care of. Moving on from here, we do need some more global variables. So we need global lower trigger and global raise trigger. Now you've seen me use triggers before with a range mapper, and that's exactly what we're going to be doing here. But on this occasion, we cannot make do with a single trigger. We do need two separate triggers. I've tried it with a single trigger and it doesn't work. So that's why I'm doing this. Finally, we need global start time. And once again, you've seen me create this variable if you've done any of my other Python tutorials involving range mappers. Okay. The next thing is the ubiquitous frame variable, as I do so often. So frame is equal to doc get time get frame doc get FPS open double close. So that gets our frames from the timeline. Moving on from here, we can say if frame is equal to 0, so when we're at the start of our animation, and then we can start to initialize our variables. So we can say start time is equal to an empty list, and the same with lower trigger. And I'm also going to grab this from here to speed things up a little bit, and we can say the same with raise trigger. They're both empty lists. And then our output stage can simply be 0, so L underscore R is equal to 0. So that initializes our variables at the start of the animation. We now need to start looking at what's coming into our, if we just open this, we need to start looking at what's going to be coming into these two inputs here. So we'll start by saying if down is equal to 1. So if we've had a collision here between these two nulls, so if our first checkpoint, in other words, is giving us a collision value, if the trader's passed through it, then we obviously want to trigger the barriers being moved down. So we'll put a colon on the end of there. So if down is positive, if it's happened, we want to say if len, and it will be lower trigger, is less than 1, lower trigger dot append 1. We can then say if len start time is less than 1, start time dot append frame. So we want to get the current time. Moving on from here, we can say if len lower trigger is equal to 1, and at this point we want to start lowering the barriers. So we can say duration is equal to frame minus start time brackets, in fact it should be square brackets, 0. So whatever we've got in our start time, whichever frame it grabbed, we need to subtract that from the current frame to zero things out, and then we'll trigger our range mapper from there. It works exactly the same way as the range mapper in the Expresso, as I've said before. Okay, let's get to the all-important stuff. So we want this to happen over 90 frames. So we'll say if duration is less than 90, range underscore mapper is equal to, and it will be c4d.utils, because the utilities module is where the range mapper is stored. Range map brackets duration, and we'll obviously start at 0 and we want to finish at 90 frames. Moving on from here, we can look at our output range, because these two are the input range of the range mapper, and we'll say 0, 90 once again. Then we need to say false, comma, and we're also going to say spline, and I haven't developed the spline yet, but I'm going to. So what I'll do at the moment, in fact, is just leave that blank. I'll leave it at false. Okay, so over 90 frames, we're going to move basically through 90 degrees. So that's why we've got 0,90, 0,90. These are actually going to be degrees, okay? Now moving on from here, let's actually go to, well, in fact, what we need to do is go into we need to select our Python node, close this window, and then in the user data, add user data. And we're going to create a spline. So we'll say our data's name is spline. Select the spline in here, and then we'll do some work. What I'll do, if I just, for now, well, in fact, I'll say OK, and in here, hold down my command key and add a point, hold down a command again and add another point, and I'm going to leave that at that for now. Okay, we'll come back to it a little bit later. So spline is now created, and what we can then do is actually drag, or click and drag this into the window here, drop it in there, and say spline, oops, if we spell it correctly, spline is equal to op c4d.userdata identifier 1, ID 1, and then we can copy this, or in fact we don't need to copy it, we can just simply say comma spline in there, and that finishes off the range mapper. Moving on from here, we can simply say our underscore r is equal to, and again it will be c4d.utils, and it will be dot rad for radians range mapper. Just get that in lowercase, range mapper. So we're going from 0 to 90 degrees, but we do need that in radians, because obviously Cinema 4D works internally with radians, and we won't be adding a degree node between what's coming out of here and what's going into these. Okay, so we're getting radians out of here, which means we can plumb them straight in. So that's why I'm doing that. To finish this off, we simply need to say else lower trigger equals an empty list again, or rather what we'll say is lower trigger.clear, and do that, and start time dot clear, and that sets both of them back to their initial states. So that's what we need to do there. Now, we can simply copy all of, let's have a look, see what we can copy. We can copy, yeah, we can copy all of this code actually from here. If we just copy all of this, we can now say if up is equal to 1. And we've got to change everything here. So we've got to say raise trigger in here. All of this has got to be just altered to accommodate this. Raise trigger. Start time is obviously going to be the same. Frame they're going to be the same, so we don't have to change those. Again here, raise trigger. That's okay. That's all okay. Let's have a look. We need to do some changes here. Yes, we simply need to change 90 to 0 because obviously the barriers will be at 90 when they're lowered, and we need this to reverse and go from 90 to 0. So that's why we're doing that. Okay. So that's fine. That's all good. And then again, we can just say in the else, raise trigger. And that is as much code as we need in order to make all of this work. Hopefully I haven't made any syntax errors and it will all hang together nicely. The next thing we need to do then is open this up again and connect everything up. So we'll connect this to here and this to the up, and then connect these up as follows. So that's fine. Everything is now connected, and we can give this a test run and see if it actually does work. Right, so let's give this a go. See what happens. Right, we've got a problem. So range mapper is not defined. What have I got? Ah, okay, I have got a syntax error. There you go. I always get one. Let's have a look, see what we've got. Where is it? It's line 33. So, okay, there we go. Let's just take that out, put that down, and hopefully that solved that one. Let's see what we get now. And straight away our barriers come down, as you can see. I'll tell you what we'll do. Let's just go into, I've got a stage object here. I'm just going to click on that, and we'll set it up with the stage object so that we can see more clearly what we're doing. So let's have a go. And down they come. And let's see if it works the other way. As we go away, we're going to hit our next checkpoint just about now. And we've got another problem. So I've still got a syntax error, of course, because I copied. So let's just take that away. Go back to the beginning and have another go. Down they come. And when we hit the next checkpoint, it should raise. And they do. Beautiful. Okay, so it's all working and it's all looking good. Now, the last thing I'm going to do is work with the spline, because at the moment, I mean, if we just run this a little bit and just see what we get. Now, they're a bit sort of, well, a bit sort of kind of stilted, really, isn't it? It's not very sort of lively. It could do with being a little bit more dynamic. When they actually come down, they could do with wobbling a little bit, because barriers often do, don't they? And the same thing when they go back up, they can wobble here too. So we can do that by using the spline and adding some more points and doing a bit of manipulation in there. And that's going to be the next thing we're going to do. Rather than work in here, I'm just going to open a new window. Twirl this open so that we can see where we are and what we're doing. And I think probably round about 0.8 we should be okay to work somewhere there. So if we set this to 0.8 in here, that should place our point where we want it. And we'll bring this up so that our point is set to 1 along its y-axis. And it's going slightly above, which is fine. That's what we want. So we can just bring this so that we get a more linear curve there. And then we'll add another point here and place this one somewhere here. Now, this is something you do by trial and error, really. There's no absolute right way to do this. But what we're just trying to do is just create a little bit more dynamics in here. So once again, we can place this point at 1 along the y-axis and then work with the tangents so that we get what we want. In fact, we'll move this tangent here. That will give us, so that pushes it above. That's fine. And then we can just drop this down there somewhere. If we can just do the same with this one, we just get a hold of a tangent here, just move that up a little bit. And then this one here is a funny sort of shape, but if we just pull that in there, say about there, hopefully we're getting something that's about right. We'll move that slightly down. And then we'll put another point in and move that one. Again, we can have a play around with tangents on this. It just needs to be a bit closer. And then perhaps up a little bit so that it's just above. I don't want it too far above, just above. And that one can move down a little bit as well, so we're getting a little bit of variation there. And then one last point, if we just pull this one over here so that it's just below the line, that should do us for our points. If we just move that one along a little bit further and that one along a little bit further, I think that'll do as a basic setup. It won't be 100% perfect, but let's just see what that does. If we just run the timeline, let's see what happens now. Let's go back to the beginning. Just run this. I just want to see what happens. Okay, so we've got that bit of a wobble in it, and it will do the same when it goes back the other way. Okay, looking good. Let's just change to our right view and see what we've got. Let's have a quick look. Let's have a quick look. So if we move down, now we can see that there's a slight problem because these are still past the 0 point. The 0 point is on this line here. So we're going too far. Now, why is that? Well, I mean, our last point here is where we would think it would be. It's in the correct place. But the reason for it is because what we need to do is actually select all these points and just move them along a little bit. Now, let's have a quick look, see where we are. And then what we can do here, this should be flat now. If we need to, we can add a last point, but we'll leave that as it is and we'll see if it makes any difference. Let's just go back to the beginning. Already, now if it go to start, you can see that it's jumped back to the correct position. So that's all sorted out now. So that solved that problem. So make sure you get your last point away from 1 along the y-axis, the x-axis. Make sure it's not at 1 on the x-axis, and that will solve that problem. So let's just play the timeline. We'll go back into our 3D view and play the timeline. There we go. That's working quite nicely, actually. And let's see what we get here. And actually, we'll pause that there and go to our in view there, or our right view, and we can see again these are perfectly aligned. Now if we hadn't done this, they wouldn't be. They'd be actually slightly down here somewhere. They'd have gone slightly over. So that's perfectly good. So let's just play through. Up they come. And they do the wobble. That's fine. I mean, I'm not going to go any further with this. Again, as I say, you can fine tune this to your heart's content. But I'm not going to go any further. But that's the kind of thing you need to do there. Okay, so let's just close this window down. Now, in the range mapper, I've got here false, and in this one, false. Now, you might say, well, if you're going from 0 to 90, we're counting from 0 to a positive number. So normally you could use true in there. However, the reason we've got to use false is because we've gone above the range. If we just open that again, we can see that this is above the range. This is above, well, it's above 1 on the y-axis. And that means that we've gone above 90. So if you're going outside of your range, you must use false. Down here, we're going from 90 to 0. So you have to use false anyway. You're forced to use it there. But because we've got this in, that makes it doubly important. So that's why both of these are false as opposed to the top one being true. Hopefully that makes sense. But anyway, let's just go into our standard view now and give this a play through. And we'll see it working very nicely. Yeah, that's fine. It's a little bit exaggerated, but it doesn't matter. It's, as I say, have a play around with it to your heart's content and get it the way you want it. Yeah, and it all works fine. So that is how you go about creating a level crossing using a combination of Expresso and Python. Let's just go back into our script here. Select our no, don't do that. Select our Python node. We'll get the code back up so you can see it. And you've got the two of them there, and there you go. So that's how you go about doing it. As I said earlier, it's mostly Python, but much of it you can actually cut and paste, so there's not an awful lot to it really. So it's not a particularly complex expression at all. It's just a couple of range mappers, a couple of ray collision nodes in here to trigger the range mappers, and the output plumbs in to the rotation P of the two arms. And that's all you've got to do, and it's all triggered by the targets. Really simple. So the targets and the loco. And that's it. That really comes to the end of this tutorial. That's what I wanted to show you. So as I always say, I hope this has been of interest to you and you've found something new that you can use maybe elsewhere in a project of your own. And if you have enjoyed the tutorial, then please give it a thumbs up. And if you haven't already, please subscribe to the channel. And of course, leave a comment and ring the bell. And wherever you happen to be on social media, then please share this video, because all of this good stuff helps to keep the channel moving in the right direction. And at some point in the future, I will be returning to trains again, because I'm planning to do a tilting train mechanism, and that will be another Python and Expresso tutorial. So keep tuning in and you'll see that one in the not too distant future. But anyway, that completes this one. So I hope you've enjoyed it, and I'll see you very soon on the next tutorial.